Well, hi everyone. Okay, we've got this parent functions. We're also going to, as we talk about parent functions, we're going to talk about translations on some of these parent functions. First parent function we're going to talk about, this is the function that all the other of this kind build off of, is a constant function. And if our function is f of x equals c, where c is just some number, it's not a variable, it's just any number that could be put there, any real number. F of x equals c, another way for functions is y equals c. They're the same thing. These are equivalent ways of writing it. So it's hard to just figure out whatever c is. Let's say y equals 3 or f of x equals 3. If you remember, y equals, that's hoi. Remember that? It's a horizontal line. Y equals 3. Y is always 3. Y is always 3 no matter what x is. So we have this, let me change colors here. Go red. Y equals 3 is this line right here. And I'll just kind of highlight that a little bit. Alright, so the constant function is a horizontal line function. This is a specific constant function. The general identity function, this is f of x equals x, or y equals x is the equation. So here's the equations for the identity function. And 0, 0 would be a point where the y coordinate and the x coordinate are the same. 0, 0, 1, 1, 2, 2, 3, 3. So it really just follows that diagonal right there. Negative 1, negative 1, negative 2, negative 2. It splits the first quadrant right in half and the third quadrant right in half. So I'm going to just throw a straight edge down here a little bit and graph that. Put an arrow on each end because it keeps going. Now the absolute value function is another one of our parent functions, and this is f of x equals the absolute value of x, or y equals the absolute value of x, either way. This is the function notation, and I want you to, let's just look at that real quick and put an x and y, and let's go negative 3, negative 2, negative 1, 0, 1, 2, and 3 in x, and then figure out what y is. Well, it's the absolute value of negative 3, which is 3. Absolute value of negative 2 is 2. Absolute value of negative 1 is 1. Absolute value of 0 is 0. The absolute value of 1 is 1. Absolute value of 2 is 2, and absolute value of 3 is 3. So let's see what that looks like on the graph. Negative 1, 2, 3, positive 1, 2, 3. Negative 2, positive 2. Negative 1, 1. 0, 0. 1, 1. 2, 2. 3, 3. And if you'll notice, this is the identity. That's the same thing as this part right here is the same right here, except it doesn't go down there, it comes back up because the absolute values of negatives are positive. So it makes a V shape. And let's get that graphed really nicely here, because this will be a reference graph when we start doing our translations and our transformations. So it's good to always make a good parent function graph. Okay, so this is the absolute value, and it makes a V. The quadratic function is f of x equals x squared. That's the standard one. Or again, y equals x squared. Now, if I do the same thing, -3, -2, -1, 0, 1, 2, 3, I'm just getting the parent function graphed real nicely so that we can go pretty quickly when we have. So when we square -3, we get +9. When we square -2, we get +4. When we square -1, we get 1. When we square 0, 0. 1 squared is 1, 2 squared is 4, 3 squared is 9. Notice the reflection there is what we're going to have. Now -1, 2, 3, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. -2, 4. 1, 2, 3, 4. -1, 1. 0, 0. 2, 4. Not 1, 1, sorry. 2, 4. And 3, 9. Okay, I like to make this curve down here. It's not a V. It's not a point. It's a curve down here. And then just kind of draw this through here like this. So just be able to slide these things around. That's the translations that we're going to be working on. One thing I want you to notice that their distance from here to here, where these first points is 1, and from here to here it's 1, 2, 3, 1, 2, 3, 4, 5. If I were to go another one, I would go from this level, I'd go 7 units up to the next one. I just run out a graph for that. So here are our parent functions: constant function, identity function, the absolute value function, and the quadratic function. Be familiar with those. Now, the ones I want to deal with here, I want to start talking about translations. And that is just sliding the parent graphs around. I want to deal with just the absolute value and the absolute value and the quadratic. So, first one I want to graph, I'm going to graph f of x equals the absolute value of x minus 3. So, let's remember the absolute value of x. I'm going to graph that. Remember 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, and -1, 1, -2, 2, -3, 3. I'm graphing the parent function. This is f of x equals the absolute value of x, what I'm putting on here right now. Okay, so that's the parent function. This is the one that all these others are going to be built off of. Okay, I'm going to make a little table here. X, absolute value of x. I'm going to just do like -2 to +2. -2, -1, 0, 1, and 2. And remember, this is 2, 1, 0, 1, 2. Now, let's deal with this absolute value of x minus 3. So that's taking this value and subtracting 3. So 2 minus 3 is -1. 1 minus 3 is -2. 0 minus 3 is -3. 1 minus 3 is -2. And 2 minus 3 is -1. Okay, so let's just look at that, where that puts us. This is still my x. This is my new y, though. I'm skipping over this. But I just took all these absolute value of x's and subtracted 3 to get this column. Here's my x coordinate. Here's my new y coordinate. I'm going to change colors. This is going to go green here. negative 2, negative 1 is right here. Negative 1, negative 2. Negative 1, negative 2. 0, negative 3 is right here. 1, negative 2 is right here. 2, negative 1. So you see now we're following let's see, I want to be a little more careful than that. Kind of follow this line here. And every single point, this point is dropped 1, 2, 3 points here. This point's dropped 1, 2, 3. Okay, so I want you to notice how that's sliding from the parent function. Now, I want to look at what f of x equals absolute value of x plus 2. Okay. So on this, we got the absolute value of x plus 2. So this is the absolute value of negative 2 plus 2, which is the absolute value of 0, which is 0. This is the absolute value of negative 1 plus 2, which is the absolute value of 1, which is 1. This is the absolute value of 0 plus 2, which is the absolute value of 2, which is 2. This is the absolute value of, I'm on this line right now, try to keep that straight a little bit, of 1 plus 2, which is the absolute value of 3, which is 3. This is 2 plus 2, which is the absolute value of 4, which is 4. Okay, so now let me plot negative 2, 0. I'm going to go blue on this one. Negative 2, 0. Negative 2, 0 is right here. Negative 1, 1 is right here. 0, 2 is right here. 1, 3 is right here. 2, 4 is right here. Okay, I think I'm seeing what's happening, but I want to do one more thing. I want to put a couple more values in. I'm curious on this side where negative 3, what happens there? We take the absolute value of negative 3 plus 2, which is the absolute value of negative 1, which is 1. So negative 3 is 1. So do you see the bend here in the absolute value? So in blue, I should have kept, I'll try to do this right. This is in blue. Okay. Follows right along there. Now notice from my parent function that this one is going 3 units down. It's sliding 3 units down from the parent function. The parent function's in red. This blue is sliding, look at this, there we are, we're sliding 1, 2 units to the left, and we've got, and this one's 2 units left. Okay? And then if I were going to graph, let's see, go black here. F of x equals the absolute value of x plus 2 minus 3. I would slide 2 units left like this one does, and I would slide 3 units down. So if I slide 2 units left, 1, 2 units left, and 3 units down, 1, 2, 3. Here's my bending point for that. Here's the origin where the parent function, and I'm sliding 2 units left, and 3 units down. Okay. So this point, 1, 2 left, 1, 2, 3 down is right here. So it's going to go like this. This can get confusing, especially if you're not changing colors. All right, now I want you to write a generalization here. I tried to illustrate it, but f of x equals the absolute value of x minus h plus k. K and h are just some numbers. X and f of x are like the variables still. You would slide the graph of f of x equals the absolute value of x. That's the parent function. You would slide the graph of the parent function. See, if it's positive 2, I went left. If it's a negative, I'm going to go right. I'm going to say h units right. And notice the minus 3 did take it down, and 3 units down. But if it's positive k, and k units up. All right. So that is that, and just keep that in mind. I'm not going to go quite into depth here. I did want to do a quadratic here, but not as many. I'm going to do one. Okay? Now that we kind of have this general rule. Okay, for this one, let's do f of x equals x minus 2 squared plus 1. Okay, I am going to graph the parent function, f of x equals x squared. I'll do it in red again. Okay, remember 0, 0, 1, 1, 2, 4. I'm just going from what we did on the other side. 3, 9, 4, 5, 6, 7, 8, 9. And then on this side, we have the same thing. Negative 2, or negative 1, 1, negative 2, 4, negative 3, 9. Okay. Oh, that parabola, right? Remember calling this thing a parabola in Algebra 1? Still a parabola. Okay, so you have this. Now, we're going to slide the parent function 2 units right. If it's after a minus, now that's kind of counterintuitive for me, but that's the way it works in the parentheses. 2 units right, and 1 unit up. I'm going to slide this 1 unit up. So, do this in black. I'm going to take the vertex here, go 1, 2 right, and 1 unit up, and there's my new vertex. I'll take this point, go 1, 2 right, 1 unit up, and there's that point. Take this point, 1, 2, and 1. Let's take this one, 1, 2, and 1. Let's take this point, 1, 2, and 1. This point, 1, 2, and 1. This point, 1, 2, and 1. All right, and then I'm gonna connect everything. This is, remember, this is a curve. This is not a straight corner that curves through the vertex. It does not come down and make a V or anything like that. So I slid it 2 units right, 1 unit up, based on that. Let's do right this. F of x equals, let's write this as x minus h squared plus k. For the quadratics, we will slide the graph of f of x equals x squared, just like this other one, h units right and k units up. Okay, now I know we've been here for a while. This is one of the longer videos, but I want to just do one more thing and talk about each graph here, what its equation would be. For this one, it is what kind? If you said absolute value, you are correct. So I'm going to put an absolute value bar. I'm going to put an x. Now notice we slid this 1, 2, 3 units left and 1 unit down. Now left inside with the x is plus. And that's, again, counterintuitive, I know, but that's the way it's working right now. And then 1 unit down. Now that goes according to our instincts, I think, on that. So that's that equation. This one, I'm sliding from the origin, this parabola, 2 units right and 2 units up. So I'll call this one g of x. G of x, and now it's quadratic. So I'm going to use parentheses and square, and I'm going to go x. I'm going 2 units right, so I'm going to go x minus 2. Minus is right. Plus is left with the x, but plus is up over here, too. So that's that equation. See if that makes sense. Sliding 2 units left, sorry, that's right, 2 units right and 2 units up. And then you got 2 more here. I'm going to go h of x for this one. H of x, I'm going to slide 1, 2, 3, 4, 5. What kind of are we dealing with here? Another absolute value. I've slid 5 units to the left. That would be x plus 5, counterintuitive. And then go 1, 2, 3, 4 units up. H of x equals the absolute value of x plus 5 plus 4. Here is the quadratic function. I'll call this one, I is not a good one. I'm going to call this j of x. This one is j of x. And it is the quadratic function. So it's going to be squared. So I'm going to take the x. I slid it 1, 2, 3, 4, 5, 6, 7 units right and 3 units down. 7 units right, that's x minus 7 squared. 3 units down, that's a minus 3 there. Alright guys, long video I know. Thanks for hanging in there, and I will see ya in class on Thursday.